Hello and welcome to CMC Math 121. This is the college algebra course, and this is the first video in that course. And what we're going to be doing is a review over factoring polynomials. Okay, so this is section P5, and what we're going to do is do an overview of factoring. Okay, factoring is something that you guys have all done before. In order to get into college algebra, you have to know how to factor. So this is a section to review what factoring is and how we do that. We are going to cover probably all types of factoring in this very quickly. And, without factoring, we can't do a lot of stuff. So it's really important that we know how to do this and that we practice. So over here on the left side, under your objectives, are all the different ways that you can factor, okay? And we'll go through what each of those are in this video, but I want to talk about just kind of some basic concepts of factoring. Okay, so let's say that I want to factor a number. Okay, factor a number. What this means is that I rewrite as multiplication. So rewrite as multiplication. So let's just take the number 6, for example. Okay, if I wanted to factor 6, I would factor it to, say, 2 times 3. Okay, this action here from going from 6 to 2 times 3 means that I have factored 6. Now, I can factor 6 a number of ways, but that's what that means, okay? Now, the other thing that we did, factoring, another way to think of factoring, is the opposite of FOIL, okay? And let's say that I want to multiply two binomials together. Okay, so let's say I have like x plus 2 times x plus 3. Okay, we'll use 2 and 3 just like we had. Now remember, if we do FOIL, that's the acronym for first, outside, inside, last. So if I multiply my first terms together, all right, that's just going to give me x times x, which is going to give me x squared. Okay, if you multiply your outside terms together, you have x times 3, so it's going to give you plus 3x. If you multiply your inside terms, it's 2 times x, so it's going to be plus 2x. And then if you multiply your last terms, 2 times 3 here, you're going to get plus 6. Okay, and so what we can do is we can combine our like terms here in the middle, and we get x squared plus 5x plus 6. Okay, now, going in this direction here means you multiplied. Okay, what we want to do is we want to go backwards. Okay, we want to go from here to here. And what this is going to do is this is going to allow us to factor. Okay, and it's the opposite of FOILing. Okay, so that's what essentially we're doing in this section. Okay, is we're going to go from this trinomial here and bring it back to the product of binomials. Okay, so let's do this. Okay, we got a couple different methods. I want to talk about the box method. Okay, especially for trinomials. So the box method. I want to talk about that first. Box method is this. So let's say I have the same thing. Okay, we're going to do x plus 2 times x plus 3. Okay, and I'm going to multiply that together. I'm just going to show you how the box method works via multiplication first. So I'm going to take x plus 2. I'm going to put those numbers here above each respective column. And then I'm going to put x plus 3 back over here on the left side, okay? And so if I do this, if I take x times x is going to give me what goes in this box, okay? If I take x times x, that's going to give me x squared, okay? In this box here, I'm going to take x times 2, and that's going to give me 2x. Okay, in this box here, I'm going to take x times 3, which gives me 3x. Okay, and then I'm going to take 2 times 3, which gives me 6. Now, you should see that we're getting the same thing here. And then what I want to do is I want to add up all of the boxes, okay? And so I'm going to take x squared plus 2x plus 3x plus 6, and it's going to give us the same thing that we had, which was x squared plus 5x plus 6. Okay, and we're done. Okay, we've multiplied. Now, okay, remember, all we're doing here, the prompt here is that we want to multiply. Okay. Now, I'm showing you that because the next part here we want to factor, okay? So let me factor this, okay? And we want to factor x squared plus 5x plus 6. Now, I'm going to use the box method to do this, okay? And it's kind of nice to have these side by side to kind of help see why I'm doing this. But let's put my first term, my x squared, in this box. Let's put my last term, 6, in this box. And what I want to do is I want to figure out what's going to go up here and over here, okay? And we have our example here, so we already know what's going to go there. But the question I ask myself is, what two numbers are going to multiply to give me x squared? What two things can I multiply together to give me x squared? And that's simply just going to be x and x, okay? Now, the next question I ask myself is, what two numbers are going to multiply together to give me 6? And those numbers are going to go here and here, okay? Now, you have some different options. Now, since we already know the answer, we know that it's going to be 2 and 3. So I'm going to do a plus 2 and a plus 3. All right, so now what I do is I want to verify that this is right, okay? So I'm going to do 3 times x, so that gives me 3x. I'm going to do 2 times x, which gives me 2x. And all I'm going to do now is just verify that these numbers add up to my middle term here, 5x. So if I take 3x and add 2x, it's going to give me 5x. And that is my middle term here. So this is right, okay? And that's what we're looking for. And we'll do a bunch of examples to kind of make sure we understand that concept. But the idea is that I'm using this box method to verify that this factors to x plus 2 times x plus 3, okay? So factoring and multiplying, they're just kind of opposites of each other, okay? Factoring is just rewriting it as multiplication. Okay, so that's kind of factoring in a nutshell, okay, is, we have this one thing here where we multiply out, factoring is going backwards, okay. Now what I'm going to do is let's go through these problems here and factor these, okay. Now, each of these are different, okay. The box method was an example for a trinomial, something with 3 terms. What I notice here is that this only has 2 terms. Okay, in this example, when you just have 2 terms, you want to look to see, is there a greatest common factor? Is there something that's a factor of both of these that I can factor out? Now, when I have this, okay, in this type of situation, if I'm factoring using the greatest common factor, I need to think about the distributive property. This is the opposite of the distributive property. Okay, and so if we distribute, we can always check to see if we're right. All right, so let's do this. Let's think of, the numbers 10x cubed and 4x squared. Let's just do this. Let's just take the numbers first, which are 10 and 4. And I'm going to list off the factors of 10 and the factors of 4. Now, the factors of 10 is going to be 1, 2, 5, and 10. And now how I know that, 1 and 10 multiply together to give me 10. 2 and 5 multiply together to give me 10 as well. Those are the only numbers that are going to multiply to 10. Now, if we look at 4, okay, 4 is going to have the numbers 1, 2, and 4, okay, and that's it. All right, so those are the factors of that. All right, let's take a look at the factors of x cubed and x squared. Now, x cubed, the factors of that is x times x times x, and the factors of x squared is just x times x. Now, what we want to do, the reason why I'm doing this is we want to figure out what our greatest common factor is, and it's what's common between each of these groups. Now, if I just group my numbers together, okay, the largest number that's common in both of those lists is 2. Okay, if I group my variables together, okay, the common values is x squared. Okay, so my greatest common factor is going to be 2x squared. Now, what I want to do is I want to factor that out. Okay, so what I'm going to do is I'm going to take 10x cubed minus 4x squared, and I'm going to factor out, do the opposite of the distributive property for 2x squared. So if I factor out 2x squared, okay, I am left with 5x minus 2. Now, the reason why I was able to automatically do this is because I'm asking myself the question, okay, if I factor out a greatest common factor of 2x squared, what would be left over for me to get back to 10x cubed minus 4x squared? And so what you have to do, this is my answer, okay? But I can check by distributing. All right, so if I do that, if I distribute my 2x squared into here, so 2x squared times 5x, 2 times 5 is 10. X squared times x is going to give me x cubed. If I take 2x squared and multiply it by negative 2, that's going to give me negative 4. 2 times negative 2 gives me negative 4. And then an x squared, and that's the same thing that we started with, okay? So this is my answer here, okay? Make sure that that's our answer, all right? And that's that. All right, now let's take a look at the next one. Okay, I want to factor this guy over here. Now this one's a little bit interesting because I have 2x times the quantity, x minus 7, plus 3 times that same quantity, x minus 7. So when I look at this, I have a common factor of x minus 7. So what I want to do is I want to factor that out. I want to do the opposite of the distributive property. So I'm going to take this guy out. I have x minus 7. And now what I'm left with is the 2x plus 3. And that's that. This is my answer, okay? All right, so those can be a little tricky, okay? And this is a good, useful step when you see something like this. To the next one we're going to do. So all of these were done by the greatest common factor, okay, which is the opposite of the distributive property. So parts A and B here are done by that problem, done by that type of problem, okay. Now over here, when I have 4 terms here, okay, so 4 terms usually indicates that we're going to do factor by grouping, okay. So factor by grouping. All right. And so here's what I got. Factor by grouping. What I want to do is I want to group each of these individually. And I'm going to turn this into a plus negative here. All right, just to make life a little bit easier. And what I've got is I want to look at this first group and ask myself the question, what can I factor out of this first group? And the first thing that I can factor out is an x squared. Okay, so if I factor out an x squared, then I'm left with an x plus 5. Okay, now over here, I can factor out a negative 2. So if I factor out a negative 2 here, I'm left with an x plus 5. Now, when I group these individually, okay, like this, and then I factor them, notice what happens. Notice how I get an x plus 5 out of each of those. Because that's a common factor of x plus 5, I can factor that out. X plus 5, and then I'm going to multiply. Well, think about what you're left over. You're left over with x squared minus 2, and that's going to go into here. Okay? This is my answer. Okay? And we can check this by graphing or by multiplying it out, but I'm not going to do that right now. Okay? Let's take a look at the fourth one. Okay? I want to factor this one. Now, this one's a trinomial. Okay? This has 3 terms. Okay? So because I have a trinomial, what I want to do is I want to use the box method. Okay? You don't have to, but it's probably going to be easiest. All right, so what I'm going to do is I'm going to do that same thing that we did. I'm going to put my first term of x squared into this box here, x squared. I'm going to put my last term 40 into this box down here. Okay, now what I need to do is I need to figure out 2 numbers that are going to multiply to x squared. All right, so that's going to be x and x. Now, I want 2 numbers that are going to multiply to 40. But remember that both of these boxes here and here need to add up to 13x. So we kind of got to be a little strategic about this. And what I want to think about, 2 numbers that multiply to 40 that would also add to 13 would be 5 and 8. So I'm going to do plus 5 here, plus 8 here. So what's going to go in this box is going to be 5x. What's going to go in this box is going to be 8x. Okay, and when I combine those boxes, what I'm going to get is I'm going to get 13x. Okay, therefore, this is done, and this is correct. Now, this factors to just what I have above my box and on the left side of my box, which is going to be x plus 5, and then x plus 8. And that's it. That's all I'm doing. Okay, so that's the answer. All right. All right, let's take a look at a couple of others. All right, this is a trinomial. So I'm going to do the box method on this guy. So I'm just going to draw my box. Okay, and then I'm going to put my first term, x squared, here. I'm going to put my last term, negative 14, here. Now, 2 numbers that multiply to x squared is just going to give me x and x. Okay, now on this one, it's a little bit different. I need numbers that are going to multiply to negative 14, okay? But then at the same time, they need to add to negative 5. Now, what you can do is you can just try different numbers, and you can do guess and check, and you can draw, multiple boxes when you do this, or you can kind of think about it. It kind of depends, all right? So, what I think about, between, multiplying to 14 and adding to, multiplying to negative 14, adding to negative 5, let's do negative 7 and positive 2. Okay, and here's what's going to happen. Okay, I'm going to take 2 times x, and that's going to give me 2x. Here I'm going to do negative 7 times x, and that's going to give me negative 7x. Now what I'm looking for is this. I need to combine my like terms on this diagonal. Negative 7x plus 2x is going to give me negative 5x. That's what we're looking for here in my middle term. Therefore, my answer is going to be what's left, x minus 7 times x plus 2. Okay, and that's how you factor those. All right. Now let's take a look at the next one. Okay, now this one's a little bit different because you have a leading coefficient of 6. It's still a trinomial, but it's a little bit different. Okay, so let's take a look at what we got. So I'm going to do, I'm just going to draw my box, and this might be some guess and check. Now I'm going to go through this and show you guys a couple different ways to do this. So I'm going to put 6x squared here, and I'm going to put negative 7 there. So what you have is, let's think about 2 numbers that are going to multiply to 6x squared. Okay, and that would just be 2x and 3x. Okay, now, all right, we want to think about numbers that are going to multiply to negative 7. Okay, so let's do this. Let's do a plus 1 up here, and let's do a negative 7 here. Now, what we're doing, this is what we, and I'm doing this, guys, just to kind of show you, that there is a trial and error process to this, okay? So I just chose different things. I said, let's see if that's going to work, okay? So I did 2x here, 3x here, 1 here, negative 7 here. This is one combination of things that we could do, okay? I may have to move some numbers around to see if this is going to work, okay? So let's just try this one and see what happens. So in this box over here, I'm going to do 3x times 1, which is just going to give me 3x. Here, I'm going to do 2x times negative 7, which gives me negative 14x. And so when I combine my like terms, do I get 19x? That's the question. So negative 14x plus 3x is going to give me negative 11x. And this does not match. No. Okay? What we want to do is we want to make sure that those match up. So this combination of numbers is wrong. All right? So let's try something else. Okay, so let's draw the box again. All right? And I'm going to put 6x squared here. I'm going to put negative 7 here. Now, 6x squared, let's continue with putting 2x here and the 3x here. Now, the issue is that I had, with these numbers that I had, with two numbers that are going to multiply to negative 7, I don't have that many options. I just have 1 and 7, basically. So let's try this. Let's try moving this one up here and making this negative. So 2x minus 7 and then 3x plus 1. Now, what's going to happen is I'm going to get negative 7 times 3x, which is going to give me negative 21x. And then I've got 1 times 2x, which gives me positive 2x. Now, when I combine these, I get positive 19x. Well, I get negative 19x. Okay? So this one is still wrong. No. Okay? And what I realize is that since I got a negative number, negative 19x, and I want to get a positive 19x, all I got to do is switch that up. All right? So let's do this one more time. All right? So I'm going to put the 6x squared down here, put a negative 7 here. I'm going to do 2x, 3x. This is going to be negative 1. This is going to be positive 7. So that's going to give me positive 21x, and this is going to give me negative 2x. Combine your like terms here, and that's going to give me 19x. Positive 19x, that's what we're looking for. We are good. So this factors to 2x plus 7 times 3x minus 1. It might take you a minute to get these down, but that's okay. All right, so the reality of this is that the box method is a fail-safe way to do this. Now, if you try every single combination of numbers and you don't get anything, well, it might not be factorable. Not every polynomial is factorable. Okay, we like to think that they are, but we just got to trust the process. So, notice how, we tried these, they weren't right. Try it until you get it right. Okay, so pretty fail-safe way to do that. All right, last one over here. Okay, this one's a little bit weird. All right, so this one, notice how we have two variables. We have x and we have y. Okay, well, let's draw a box. All right, this one's a little tricky, but let's just draw the box and see what we get. So let's do... put 3x squared into this box here. So I'm going to put a 3x squared here. And then, and then I'm going to put 4y into this box here. Okay, so now I want to think about two numbers that are going to multiply to 3x squared. And that I would, let's just choose 3x and x here. Okay, now, as I'm looking at this one, we want to get 4y squared down here. This number, notice how this is positive, and notice how this number in the middle is negative. What I want to do is both of these numbers, think about it. They need to multiply to a positive number here, but they're going to add to a negative number. So they both actually need to be negative. So what's going to happen is I'm going to do this, and I'm going to do minus 4y minus a y. Now watch what happens. I'm going to get if I do negative 4y times 3x, it's going to give me negative 12xy. And then negative y times x gives me negative xy. Now, when I combine these as like terms, that's going to give me negative 13xy. I had to think about this one for a second, okay? And guys, I'm at a point where it's easy for me to do these because I've done a lot of these, okay? But it's important that, you guys, practice this, practice for you to get better at what you're doing, okay? All right, so that's that for that page. Let's go ahead and take a look at the second page. Okay, so on the second page, what I want to talk about first is difference of squares, okay? So difference of squares. Okay, and what that means is it follows this idea here where you have a squared minus b squared, okay, is going to factor to a plus b times a minus b, all right? The idea behind that, let's say you have like, x squared minus 16. Well, I can rewrite that as x squared minus 4 squared, and so that's just going to factor to x plus 4 times x minus 4, all right? And that's what we're doing. So what I want to do is I want to be able to rewrite these as perfect squares. All right, so when you have x squared minus 81, 81 is a perfect square. Let me rewrite that as x squared minus 9 squared, okay? And this then would factor to x plus 9 times x minus 9, all right? Now let's see about why this works, okay? If I draw a box and I multiply this out, x plus 9, x minus 9. If I take x times x, that's going to give me x squared. If I take x times 9, that's just going to give me 9x. If I take x times negative 9, I'm going to get negative 9x. And then if I take 9 times negative 9, negative 9 times 9, that's going to give me negative 81. Okay? So now when I add these together, I take x squared plus 9x minus 9x and then minus 81. When I combine these as like terms in the middle, they're going to add to 0 and cancel out. So what you're left with is just x squared minus 81, and that's your answer. Okay? So you could do this via the box method, but if you recognize that you have something squared minus another something squared, then you can just easily factor it. Okay, now down over here, we can use the box method, all right? And let's do that, all right? And let's rewrite this first as 36x squared plus 0x. Since there's no middle term here, okay, it's a 0. And then minus 25. Okay, so let's do the box method real quick, all right? If I do the box method, 36x squared minus 25. Okay, 36x squared, two numbers that are going to multiply to 36x squared. Let's do 6 and 6. 6x and 6x. Now, two numbers that multiply to negative 25, let's do plus 5, and let's do minus 5. All right, and look what happens. Negative 5 times 36x squared is going to give me, or no, not 36x squared. Negative 5 times 6x gives me negative 30x. Negative 6x times positive 5 gives me 30x. Okay, so when I add these together, all right, it's going to add to 0x, and that's what we're looking for. So this factors to 6x plus 5 times 6x minus 5. All right, and that's your answer. Okay. All right, let's take a look at the next one. And the next one's a little bit tricky. Okay. So let's do the box method on this. Now this one has something x to the 4th. Okay, which is okay. All right, but let's draw the box real quick. Okay, and I've got 81 x to the 4th and then minus 16. So 81 two numbers that multiply to 81. Let's do 9x squared. And let's do 9x squared here. Okay. For negative 16, let's do positive 4 and negative 4. All right. So this is 9x squared times negative 4 is going to give me, oh gosh, what do I have? 36, negative 36, x to the second power. 4 times 9x squared gives me positive 36x squared. Okay, you add those together. Those are going to cancel out and add to 0x squared. So we're good on that because there is no middle term. All right, so what this is going to factor to first is going to be 9x squared plus 4 times 9x squared minus 4. Now, when I'm doing this, all right, notice that I have the difference of squares, okay, something squared minus something else squared over here. All right, I can't do it when we're adding things together, but let's do it if we've got, subtraction. Now, the reason I can do that, guys, I can factor this further, all right, because 9 is a perfect square and so is 4. So if I put 9x squared here minus 4, 3x and 3x are going to multiply together to give me 9x squared. I've got positive 2 and negative 2, okay? So if I do negative 2 times 3x, I'm going to get negative 6x. 2 times 3x gives me positive 6x. Combine your like terms, that adds to 0x. So you're good, okay? So we had to do factoring twice on this one. Now what this is going to all factor out to is 9x squared plus 4 times 3x plus 2 times 3x minus 2, okay? So you can see that that happens a couple of times, okay? All right, let's take a look at the last one. Now, these next two are just trinomials, okay? And what I'm going to do is just factor them using the box method, okay? First term, x squared, goes here. Last term, 49, goes here. All right, two numbers that multiply to x squared, x and x. Let's give that a shot. Two numbers that multiply to positive 49, they're going to have to add to 14. Going to be 7 and 7, okay? So if I do 7 times x, that's 7x. 7 times x gives me 7x. Combine my like terms, that gives me 14x, and we are good, guys. Now, when I factor this, I get x plus 7 times itself, x plus 7. The cool thing about that is that because I have those two, I can just do x plus 7 quantity squared. And that's that, okay? So if you have the same factors, you can just write it as something squared. All right, take a look at the next one. All right, here's my box, okay? I'm going to do 16x squared here. I'm going to do positive 49 here. Now notice how 16x squared and 49, 16 and 49 are both perfect squares. So what I want to do is let's do 4x and 4x. Okay, and then they want to multiply to positive 49, but then they also need to add to a negative number in the middle. So because this number is negative here in the middle, I'm going to make both of these numbers negative. Okay, and here's what's going to happen. So let's do negative 7 and negative 7. Okay, if I take negative 7 times 4x, that's going to give me negative 28x. If I do negative 7 times 4x here, I'm going to get negative 28x as well. When I combine these as like terms, that's going to give me negative 56x, which is what we were looking for. So we've done this right. So when this factors, it's going to factor to 4x minus 7 times 4x minus 7. And because I have the same one, okay, that's just going to give me 4x minus 7 quantity squared. And that's my answer, okay? All right, the last one, we've got sum and difference of cubes. So factoring something with sum or difference of cubes, okay, and we're going to call this sum of cubes, okay, and what I have here is I have this. I have some number cubed plus some other number cubed, okay, and this is going to factor to a plus b times a squared minus ab and then plus b squared, okay? So in this case, what I have is this. I have x cubed, and I have plus 1. X cubed obviously is a perfect cubed, but 1 is also a perfect cubed, and I can rewrite that as just 1 cubed. Okay, so what I'm going to do is that, this value here, this x is like my a, and this 1 is like my b. And I'm going to factor this. Okay, so if I have sum of cubes, here's my formula to factor that. So I'm going to be left with x plus 1 times x squared minus x times 1, and then plus 1 squared, all right? And so what we want to do is we want to simplify this, okay? And so this is just going to give me x plus 1 times x squared minus x plus 1. And this, my friends, has been factored. Now, we can't factor this any further, okay? And that's not going to work if we try, all right? Let's try difference of cubes, all right? So you have sum of cubes, you have difference of cubes, all right? Difference of cubes means you're going to do a cubed minus b cubed, okay? And what's going to happen when you do that is you're going to get a minus b times a squared plus ab plus b squared. Okay, so as a result, what I want to do is kind of look at these numbers. Now, this is a little bit weird, but 125 is a perfect cube. I'm going to rewrite this as 5 cubed times x cubed. And then minus 8 is also a perfect cube, and rewrite that as 2 cubed. Okay, so once I've done that, if I have something cubed times something else cubed, I'm going to rewrite that as 5x quantity cubed minus 2 cubed. Okay, so from here, what I notice is that this value here is my a value, this value here is my b value. Okay, so as a result, I can factor this. And so I'm going to get a minus b, so I'm going to get 5x minus 2, and then I'm going to get the quantity a, so 5x squared, plus 2 times 5x, and then plus 2 squared, okay? Now, we need to simplify this a little bit further. So 5x squared, this first part, or 5x minus 2, is going to go in my first portion. And then if I take 5x and square it, that means I'm going to get 25x squared. 5 times 2x, or 2 times 5x is going to give me plus 10x. And then plus 4, and this is completely factored, okay? And that's that, all right? So I'm only doing that because I recognize that first of all, they have cubes, all right? So you have sum of cubes, you have difference of cubes. And this is your formula on how to factor those. So you have to identify your a and your b and use that formula to factor that down, all right? All right, on this one, what I want to do, notice how I have a trinomial here. Okay, this is my last one. Now, this is where we kind of have to pull all these ideas back together. Now, what I'm going to do first is kind of realize, hey, wait a second. I have a common factor in each of these, okay? I can not only factor out an x, but I can also factor out a 3 from this. So let's factor out a 3x, okay? And what I'm left with is going to be x squared minus 10x plus 25, okay? And that's just me factoring that. What I see here is a trinomial that I can factor. And what I want to do is use the box method here and plug that in. I've got x squared and then positive 25. So two numbers that multiply to x squared is just going to be x and x. Two numbers that multiply to positive 25 is going to be 5 and 5, but they need to add up to negative 10. So I'm going to do negative 5 and negative 5. So I'm going to get negative 5x here, negative 5x here, combine my like terms, and that's going to give me negative 10x, which is what we're looking for. So when I factor this completely, what I want to do is I'm going to do 3x, and then I'm left with x minus 5 times x minus 5. Okay, that's one way that you could write this. Or you could do 3x times x minus 5 and square the x minus 5. And that's your answer, okay? So guys, yes, this is a long video. There is a lot of information in this, but the reality is that you guys have all learned this stuff. This is merely a refresher. So please get started on your homework, and we'll talk to you soon. Thanks a lot. Bye.